Morning, good afternoon, and good evening to everyone. Let's begin by introducing myself. My name is Ayushi, and I'm the Technical Performance Specialist for the School of Programming and School of AI at Udacity. So I've been a part of EdTech sector for 6 years, and it's truly my honor to contribute to the success and growth of our learners at Udacity. Welcome to our Level Up webinar series, where we are dedicated to providing value beyond the core curriculum. For you, this can be a platform to explore cutting edge innovations and gain practical insights that our mentors bring to the table from their professional expertise. I'm delighted to introduce my co host, Karan Wazirani. He's a vital member of Udacity and he's currently looking at the School of Business. And he ensures that there is smooth and enriching experience for both students and mentors throughout their journeys. So, thank you so much, Karan, for being here with us. Now, let me introduce our today's speaker, Mr. Mayur Madnani. He is a truly remarkable mentor in his journey with Udacity. He has graduated from multiple AI-focused nano-degree programs. Beyond being an invaluable member of our mentor community, he has also contributed as an instructor for one of the URC's AI courses. With a wealth of expertise spanning software development, data science, and AI, Mayur has been an integral part of Udacity family since 2020. So today he will be covering the concepts driving generative AI, and along with that, he'll be sharing some real-world use cases and live demo to illustrate its applications. So before we start the webinar, please note that the webinar will be recorded. Additionally, if you have any questions, kindly use the Q&A tab to post your queries, and we will try to answer them at the end of the webinar. So without any further ado, I'll hand it over to Mayur. Thank you so much for being with us today. Over to you, Mayur.
Thank you, Ayushi and Karan. Great to be back here. Hi, everyone. We'll be starting. Let me share my slides first. Okay, cool. So the title for our today's webinar is Generative AI Unboxed. If you're a beginner to AI or generative AI, you'll know about what exactly is this trend, generative AI, that you keep hearing all about. We'll understand what kind of different methodologies are getting used, how can you really use the technology to your advantage, and how is the future lying ahead. So with that said, we'll start. And why should you listen to me? I have some accomplishments in this area. I've been into software development and data technologies and AI for a long time. I have multiple research papers and patents, and also have contributed to a course on Udacity catalog as well. So that's about me. Now, coming to a broad description about what AI is. So you have different fields like machine learning, deep learning, reinforcement learning, and generative AI, which is the newer side of AI as we see it. Now let's understand what machine learning is all together all about. So when we say machine learning, you design a model which basically does one particular problem. It solves one particular problem. It could be as simple as identifying what could be the next price of a stock symbol that you're looking at, or it could be identifying if a customer who is looking for a loan, would he churn out or not, would he be able to repay the loan or not. So that could be a classification or a clustering problem. So you have particular problems that you are trying to solve, and that's where you use machine learning for your advantage. And there are different techniques that you can use there. Now, moving on, here you had to manually handcraft some features. Like when you are trying to identify if a customer is going to churn or not, you would look at the income sources, you would look at which location does the customer come from, and many other factors. But you need to have some understanding of, or basically the domain understanding to really apply machine learning there. But when we move to deep learning, you do not really understand the domain, but still you are able to use AI to your advantage and build solutions for it. So one example could be face recognition. And a classical case here that you would really appreciate is, go back a few years, you had COVID and then everyone was wearing masks. Now, if you use machine learning techniques to do face recognition, you would never be able to identify the person if the person is wearing a mask. But that's where the beauty of this technology lies. You do not handcraft the features, but that is something the model or your AI that you have used would identify out of the box, right? If you had handcrafted the features, you would have to really look at very nuanced details, and it's very hard to bring that into a system. So this is the speciality of deep learning, where you have very high amount of data that you pass to the model, and it identifies the patterns and identifies the different textures, patterns, whatever is required to build out your classification scenarios, regression cases, that is taken care out of the box. And now moving further, there is another class which we call as reinforcement learning, which is all about how we also as humans evolve over time. So maybe if you would have seen kids trying to walk, they fall down multiple times, and then they again get up, try to learn from their mistakes, and then improvise over it. So this is some way that reinforcement learning also works, where you make a agent work with the environment. The agent would take different actions and then try to learn from the environment. You would get rewards. It could be positive rewards, it could be negative rewards, just like a child trying to walk. Now you fail multiple times, but then at the end you start walking and even start running. Same case applies here. You get more positive rewards, you accumulate it, and those are the good actions you would take given a particular scenario. Some examples of reinforcement learning would be, let's say, self-driving cars and self-learning agents. Widely used, you would see different companies using these techniques. And again, we would see some use cases of reinforcement learning even in generative AI scenarios over course of time in the next slides. Now, coming to the main topic of today, which is about generative AI. Now, what is different for generative AI that the other earlier technologies were not able to do? It's really about generating content out of the fly. So out of thin air, you could write essays, poems, write code, create images, and basically bring out whatever you have in mind and give a sense to it. That is what this technology allows for you to do. Now, very classical case would be these days you would see many models coming out which are really good at doing problem solving and doing coding solutions as well. So they're able to compete with, let's say, somebody having 30 years of experience in software development as well. You're able to achieve that with generative AI technology. One more thing that we should also observe is over time, you start with machine learning and then towards generative AI, as you move forward, you see that we were having narrow applications. So you had specific models for regression, you had specific models for classification. And as you move towards generative AI side, you would see you have a single model which is able to do multiple things. So we are headed towards the general application, a single model able to do multiple things. And that's also one specialty where, as an industry, we are headed, which is about artificial general intelligence. So the scope becomes wider. You don't have different models for different things, but rather a single system which is able to do multiple things. Just like how we humans are good at multiple things, similarly applies in machine learning or AI scenarios as well. So broadly, these are the four categories that you would observe. uh, you do not apply generative AI everywhere. Again, there are use cases where machine learning is still relevant. There are use cases where deep learning is still relevant, and same applies with reinforcement learning and generative AI as well. So there are specific categories, and where should you apply which one is something that you would learn over time as well. Now, going deeper into generative AI, so you have something called foundation models. There are multiple companies, and you would might have heard of many of these already. Google being one of them, Meta being one of them, Anthropic being one of them, where they create different models and make it available to you. Some could release the models as open source models. Some could give you as a subscription based. So it could be Gemini or it could be OpenAI's ChatGPT. So these are all foundation models that are available to you. Now, they are trained on vast amount of data which is publicly available, but there might be scenarios where you have your own data and you would want to train it on top of it. That is the case where you would do some transfer learning, basically use the model which is already available, put in your data and make it more enriched and more refined for your scenario. That is where transfer learning helps. Again, similar things we do in deep learning and other areas as well. And the same concepts apply here, but there are specific ways of doing it. And again, once you have generative AI in the picture, you talk about transformers, LLMs, which is large language models. And all of these are basis a technique called self-attention, which is the models are able to understand what part of your prompt that you give as an input is of real importance. So you would give a prompt and it could create an image, but then what should be the focus area of the image? That is something you would identify from self-attention, which is a technique which is the basis of how these models are evolving. And Going further, as we already discussed, you have open and closed models. And again, there are collaboration aspects also. So some companies are releasing foundation models as complete open source, where model weights are available for you to download. You could run it in your own local systems. If you have good enough powerful systems available with you, you could do that. And there are also closed models where model weights and training data is not freely available, but rather there would be some research papers available, or you could look at the training benchmarks, the results of it, and use them as subscription based. So those are some scenarios which are pretty common with generative AI. And another scope is multimodal models and cross-domain generation. So by multimodality, what we mean is if you are giving a prompt and getting text as output. So it could be paraphrasing, it could be text summarization. These are all NLP based scenarios where you are giving input as a text and you're getting output as a text. But I may also ask to generate a video, or I may also ask to generate an image for me. Now, this is where multimodality comes in. Text being one modality, image being another modality, video being another, audio could be another. So these are multimodality. And if a single model is able to achieve that, that's where multimodal models comes in. And these days, we have moved away from large language models to large multimodal models. That's another term you would commonly hear. So newer models that you see, be it Gemini or OpenAI's ChatGPT, these are all multimodality already baked in. And then we also let's look at some applications. You have code generation, or we already discussed, you could just give it a prompt, ask, like, let's say you want to build a to-do application. We'll also look at some demos very soon. But with the single prompt, you're able to achieve complete websites, complete code generated out of the box for you. All you have to do is just give that prompt and start using that and build further on top of it. So that's one possibility. Even non-coders are able to work with the systems very easily. And then you have enterprise use cases. So you have large conference documents and knowledge bases in your systems lying, but you are not able to make sense out of it or get insights. This is where you could just upload your documents, and we already discussed you could do some fine tuning on the foundation models and build your own Q&A kind of a bot, for example, or auto generate some reports, make sense out of the data that you already have, which was not in a very usable format before generative AI. And there could be more use cases, especially on the creative and marketing side, where generating image banners and video content trailers is very easily automated now with this new technology. And there are many more applications. We'll also look at a few demos. So maybe let's do image generation because visual is very easy. So I'll first show you something called stable diffusion. And also note version here is 2.1. We'll come to the importance of this in some time. But in this UI, what you see is you have a prompt that you can give as input, and you also have a negative prompt. So whatever I give in the prompt is something I'm expecting in the image, and the negative is something I would not expect in the image. So I would really not want a low quality image. So I would give low quality over here and give a prompt that I'm looking out for. So let's maybe build an image which is of an insect robot preparing a delicious meal, and it should not be low quality. It should not be illustration. I'll just click generate image, and you would see an image getting rendered for me. All right, so we have 4 samples, and you see good enough high quality images because of course we said we do not want low quality. And you have 4 images of insect robot creating a delicious meal for you. You could also maybe have Pokemon fans here could build a Pikachu fine dining in Eiffel Tower. And of course, low quality is not something I'm expecting here. There would be 4 samples for this as well. All right, so you see Pikachu everywhere. So again, with a simple prompt, you are able to, in a few seconds, generate some images and build on top of it. So it could be some marketing content you are creating, or maybe just building something out. This is how you are able to use the technology, right? Now, we discussed it was version 2.1. We also have a newer version, which is version 3, again, from Stable Diffusion. So let me give a prompt here. It could be of an astronaut riding a green horse, and let's see the output here. The difference you would notice is this is a very high quality and good enough graphics that are really usable in your content. So I could do another attempt, and you would see different outputs coming out. but of a much higher quality compared to the previous demo that we looked at, right? So again, the launch of version 2.1 and 3 was just a few months apart, I would say, but you see the difference and how the technology has really evolved. So yes, a few samples that I had captured in the slides. Here I was building a small snowy mountain and a house over there in Disney style. And again, I asked on jungle some palette details and all of that, right? So you see the difference here. Really high quality is achievable. And this was just a few months away, the newer version launch. Similarly, there are many more models where you can do such kind of image generations. Uh, but before we move forward, again, let's keep it interactive. We'll have a poll. So just give me a second.
It has
All
been
right. So
launched.
the poll is launched. Please do answer. I'll give you maybe 10 seconds. All right. So maybe let's continue. So the answer here would be text prompt. You would give a text prompt and generate your image. That's how Stable Diffusion worked. And we looked at a few demos already. Moving forward, let's have another demo. And this is of another image generation tool that we'll look at. So this is from Hydream. And here, let me show you a sample first. All right, so here we are creating a dynamic graffiti on a brick wall. And here the content is hydream.ai, which would be written as text over there. So yeah, let's wait for the output to get generated. Okay, so now it should be here. Yeah, so you have a graffiti generated, and again, with a single prompt, I was able to do it. I'm just taking a sample which was kind of available for this model, but maybe I want to use the same art, but rather have a different text. So it could be, let's say I would write Udacity over here, and let's click generate. This might take some time, but we'll again continue with the details. So first of all, you're giving in a prompt here. You have the control on what aspect ratios are something you can provide. So what we generated now was 4:3, but maybe for your creative, you would want 1:1 ratio for different social media site publishing, or it could be 16:9 if you're looking at a complete wallpaper kind of a artifact, right? So you could customize that. You could give a seed. So with the seed, you are able to reproduce the images again and again. If you rerun and generate more images using the same seed, you will be able to regenerate the same image, and that is what you would see here, right? You see the very same format, the similar brick walls. You could say it is of the same location, just that graffiti is changed, right? Because I use the same seed. If I change it, you would see maybe probably a different output. So these are some of the minute details. And again, with generative AI, this is a possibility. Within a few seconds, we are able to generate fine art with a single prompt. Coming back, so we discussed about image generation till now. We looked at a few samples, but again, not applicable just for images, but let's also look at some more examples where we generate code as well. So again, going back to more demos. So we discussed about generating to-do list. So here's my prompt. I would say I want a to-do list that allows me to add task, delete task, and I would like the overall color to be purple, right? So I'll say send. And by the time this is getting generated, this is from model that you see is Quinn, which is from Alibaba Group. Again, from a Chinese side, you would say similar to DeepSeek. You have this model available as well, but really good models in terms of coding. And you would see that this is very much fine-tuned for generating web-based applications. So you would see HTML, CSS code getting generated. And if you're more of a Python person, you have another model that we'll look in some time. But yeah, let's just appreciate that it is able to complete this. And once this is done, you would see a preview rendered right on the browser. So let me close this for now and explain you this interface. Yeah, so the code was ready. You have this to-do list, and as models do hallucinate, which is something you would observe, this is not of purple color, but maybe I'm okay with it. That is something I would be able to change. But let's see the functionality overall. I should be able to add task, which I am good. I am able to delete it and also was able to list the task, right? So the overall functionality is working, just that the color is not in purple color, which is fine. But you see, just with a single prompt, again, you're able to generate a complete web-based application. You have a to-do list available for you, right? Go ahead and add more features to it, and that's all up to you. Let's look at another example where you are more of a heavy coder and you're looking at a Python implementation, maybe for a snake and ladder game. Who would not have played that in their childhood? So let's generate that right now. Uh, let's say create a snake ladder game in Pygame, which is a Python library to create GUI based games. So I set that, and you see that I am having different options for this Quen model. Again, it's a coder model, and I have different options that you see here: 0.5b, 1.5b, which is basically how many parameters this model has. I have chosen 32 billion, which is basically it might take more time to render me the output, but would be more accurate and would have lesser errors compared to if I go with 0.5b. So the bigger the model, the better your output, something like that. You can correlate. And one good thing that you would observe here is not only it creates a snake ladder game, which was my input, but it also tells you what all installations you need to do. This is your code and some instructions on how to run it and everything you have available, right? So it also gives you some notes, and you could just build on top of it, give more inputs, refine features. Again, something you can look at, right? So yeah, these were some examples where you are able to also generate code right in your browser with a few prompts. Moving on, another cool example. I really like this demo, so I would show you this. This is basis your DeepSeek models. On top of it, you have an interface called DeepSight, where it generates your complete end-to-end web-based applications. So it could be a landing page that you're working on, or maybe you want to expose your resume as a website. So different thought processes you might have. You might want to build a e-commerce store. So you can do that right from this prompt that you see here. And maybe I am interested in, let's say, luxury watches store. So I'll say create a landing page for luxury watches, right? A very simple prompt, and let's see how it does. And as it is also typing, once it completes a part of the code, you would see the updates happening right there. Within a few minutes, you would have a very elegant website generated for you. There might be a few images on and off here and there, which is something you can work on. But overall, buttons, add to cart, shopping functionality, everything would be ready for you with a single prompt. And again, it was very fast today. Appreciate that as well. It takes some time usually, but you can see the complete website is functional and even images are working good there. You see that there are some misouts here. There's no text, but something you can look at. But other than that, if I click on collections, it does take me there. You have complete functionality working right here, and this is a really good site that you can look at, built on top of DeepSeek models. So all right. We looked at images, we looked at code, and we also looked at building complete websites, again, basis some code. So these are some multimodal applications that we looked at, right? Now, moving on, it's not always a greener grass when you use generative AI. There might be some misouts, and I'll show you some real examples that I've faced myself. So I've been a heavy user of ChatGPT over the past couple of years, and you would see that I gave one prompt, which is of to create a picture of an empty room with absolutely no elephant in it. Now, I was very specific that I do not want an elephant, but you would see that it did give me elephant as well. And this is still live. The model 4.0 is still live. You are able to work with it. So that is something like a limitation that you would see. It is not really able to understand the context that I was providing it. Although I am saying no elephant, it did give me elephant, and the result is not consistent always. The same prompt, it actually gave me a room without an elephant, right? And this is a newer model, 4.5. So you would say that in 4.5, which is more of a thinking based model, it is in a way fixed. And you also have newer image generation models available now. So could be this is not reproducible, but if you just give it a shot and try it out, you might be able to see similar results coming out as well. Right? So how reliable are the model outputs is something where you might need a human intervention, and you would want to really have a cross check again if the output is really correct or is it hallucinating. And sometimes it might be very tricky to really understand that as well. Yes, so that is one limitation. But other than that, even from a research industry, there are some limitations being addressed, which is over the years, you have seen really good advancements in AI. Complete code is getting generated. The AI is able to understand and really understand you in a very personalized manner. But there are downsides to how much can it scale. Over time, it has trained on the vast amount of public data which was already available, but how can it still improve? That is where the research industry is still facing challenges. And you would see some articles where companies are saying they're not able to really improvise on it further. So that has been a struggle, and still there are researches happening on top of it. There are areas of improvement as well. So we looked at multimodality, which is still a function of improvement over time, and there are reasoning models coming out as well. But something still the industry faces issues is how to really improvise with limited amount of data that we already have. Okay, now let's look at some specific use cases. We understood about what generative AI is altogether and how does it really function, but how to implement it in your own scenarios is something what we'll be looking at in the next few slides. So first we start with RAG, which is retrieval augmented generation, and I'll explain you with a very simple example, which is I might have a question: did I meet my spending goals or not? Right now, with this question, I may not assume that ChatGPT or Gemini would know this answer because they do not know what my spending habits are, how much I have spent in the last month. So unless I give that information, the generative AI model would not be able to really address my question right away. And for this scenario, what we do is I have my own knowledge base, which could be my transaction history, it could be a spreadsheet that I maintain, or simple invoice PDFs, my income sources, or whatever it is, right? Something relevant to my spending details. If I have that available with me, I could find out what are the relevant pieces from it. So it could be my spending details, which I extract and give that to the model so that it can then answer me my question, right? Now, this is an activity that we would do where we extract the relevant knowledge which is related to the question. This is your retrieval step, the yellow part that you see. And once you have that, you add along with your question, you add those knowledge articles, or it could be different files. You add that to your LLM, which is your large language model, as we call it, the generative AI model, which you are using. So this part is the augmentation, where along with your question, you also add the knowledge that you have extracted. And once you have augmented it, the model is then able to answer because now it knows what your spending habits are. So it can answer you if you have breached your spending limit or are you still within the budget. That is your generation part. So overall, the retrieval part is where you find out the relevant information, which is more inclined to your question. You augment it to the generative model, and then you finally get your generation, which is your answer from the model. So these three steps is what RAG is all about. And this is how you can fine tune the models to your use cases. One bigger advantage here is also that you keep your knowledge private to you. You do not completely upload your 100% data to these vendors, for example, which could be OpenAI, Google, or any other that you are using. You only extract what is relevant and then try to address your answers there. So one way of maintaining data privacy instead of exposing the complete data. That's one advantage. Other is again not very relevant as of now because these models are able to access the internet and even scrape out data. But if you go back a year or so, you would have seen these errors where knowledge cutoff time was, let's say, till 2021 or 2022. Because if you at that time would have asked who is the US president, the model would not be able to know because the training was done only till a particular time. But the events that happened later after that is something the model is not aware. But that is very easily achievable here. You could feed those news articles, the newer articles from your knowledge base, and use RAG to still give or get better accurate answers, which is not a problem as of today because the models are able to access the internet. However, the other condition still applies, that you want to keep your data private, not expose everything. So that's where you would use this technique. Now, this is one good scenario, but how about the prompts? Because that is where the basis of generative AI is all about. So we'll see how can you improvise on your prompts and get more detailed and accurate answers. So for that, before we go there, first let's address a poll. Let, all right, so you would see a poll getting live now. What does the retrieval step in RAG primarily help with? Is it making the model faster? Is it reducing hallucinations? Is it compressing the model weights or generating longer outputs? I'll give you a few more seconds and then we'll move forward. Okay, so here you would want to reduce the hallucinations. That is what your retrieval part is doing. If we go back to the slide, we want to not have some random answers in my spending budgets. That's where I'm using my knowledge base and give relevant knowledge to the model so it can accurately answer me questions and not hallucinate. That's the whole purpose of RAG. Uh, cool. Moving forward, so we look at how to write better prompts. We were writing one-liners in the demos, but maybe in your real use cases, you would not want to do that. You would want to be better at your prompting so you can get more better outputs. And we'll look at a few techniques, starting with expert identity. So here, the question is describe the structure of an atom. A very simple one-liner question, and you have two different answers that you see. Let's go through the left answer first. Give it a read, and also after you have done that, look at the right answer. You'd observe that the right answer is more detailed and very stricter in terms of like you have some understanding of this concept. You are maybe a physicist, that's your background, and then you would answer the right question, get to understand the right side of the question, right? So this is where expert identity helps, where instead of just getting a random general answer, I'm saying I am aware about this topic, I have certain understanding with me already, and I want you to give me in that same level. I want you to answer me at the same level, right? Don't start as a novice, give me a detailed answer. So that's where expert identity would help. Along with your prompt, you would give a persona to your model. That's what this does. So what we have also done here is the right side is along with this expert identity, where I'm saying you are a physicist who have specialized in atomic structure. So I've given a persona to the model, and now it is able to give me a more detailed and verbose answer rather than giving me a very generic answer, which is even available on different search engines if you just search for it. So this is one really good way that you can better get more thought-provoking answers rather than just some generic answers. Now, there are some more techniques that we'll look at. So first is in context few shots or chain of thought as we call it. So first of all, maybe we are looking at translation scenario. So if you look at it, I could say I want to translate from English to French. I would just give the keyword cheese and say translate it to French, right? So that could be one case, which is okay, you would get the right translation, but I would have different level of efficiency with French conversations, right? So if that is the case, you could maybe give some examples. I could say like this is how I would want the translation to happen, and you could more fine tune your results accordingly. So in one shot, I would give one example and say this is how the translation should work. This is the language efficiency that I have, and you answer me accordingly. That is one way to better get the more accurate results here. And I could be more detailed with my prompts. I could give more than one examples, which would be few short as we call it. And along with it, you give your actual question, like I want to translate cheese, but look at these examples. And according to this, you translate the word which I am really looking at. That is few short examples. Now let's look at chain of thought. So in chain of thought, what happens is I maybe have a question. Let's look at this zero shot example, the C example that you see. Here I've given mathematical questions, and these models, generative models, are not really good with mathematics. They would not be able to really do the formulation, and you would get generally wrong answers. So here I was given a question like a juggler can juggle 16 balls, half of the balls are golf and half are half of the balls are golf balls and half of the golf balls are blue, right? So how many blue golf balls are there? Now your answer here would be, let's say, not 8, but the model thinks it is 8, because again, it would not know if it has to half the 16 balls or do some other calculation. So just giving question and expecting the right answer would not happen always. And in this case, you would give it a systematic way to address your query. So what I do here is I give a question, I give an answer, but along with it, I also explain the answer. That is chain of thought. Like, how do you really reason this question is what you are explaining step by step. So I've done that. I've given a question, I've given an answer. And again, you can consider this as a few shot example or one shot example. I've given one shot as a question answer form. And then I say, now having gone through this, you give answer to my question, which is actually the juggler question that I have, right? This is how you would get to the closer to the right answer. That is one way. And you could give more examples. That becomes your few shot basically. Now, this is something which has been in industry for a long time. Like the reasoning that you see today is at a next stage, but this is how the basic reasoning in generative models would work, where you explain step by step, and that is what your chain of thought process is all about. But now, again, this is not very efficient, and that is what we would see in the next set of slides. Before that, let's answer and poll, which is, what is chain of thought prompting primarily used for? Would you use that to train base models or to improve accuracy? Would you enable step-by-step reasoning, or do you use that for translating languages? All right, so hopefully everyone has answered. Here we use chain of thought for step-by-step reasoning. That is what we did. We give step-by-step instructions. So that is how the model is able to come to the right answer over time. If you do not do that, maybe you would not have the right answers. All right. Now, moving on. So we looked at chain of thought, but I also mentioned that may not be the right or the very accurate, the most optimal way. And we look at why. So maybe I have this question where Jason has 20 lollipops. He gave Denny some lollipops, and now Jason has 12, right? How many lollipops does Jason give to Danny? So in a way, the answer is already there in the question, but how would generative AI models work? They may not give you the right answers. So they could or they could not, right? But to be more elaborate here, you would use chain of thought, which is what we studied last time. So then you go step by step. You would say initially Jason had 20, then you give some to Denny and so on. You go step by step and finally come to the right answer. Now, this is your chain of thought. But as humans, we would not go this level at a step by step level. Some things are assumed, which are maybe already there in the question. You would not want to take that as a step, because taking additional steps here, you would see is high in number of words that you have. So models that you use, your input and your output, you are charged on number of tokens that the model is working with. That is one. Other is not very efficient in terms of computing as well. So you'd want to reduce that. Now, how do you do that? So some things which are already there in the question, you would just assume it. As humans, we assume some questions. Like, I know that Jason has 20 lollipops, right? I don't need to take that as first step. So maybe I could improvise it. I could optimally reduce these 6 steps which I have to a fewer number, and it could look something like this, which is what we call as chain of draft. So I formulate the question as maybe a mathematical equation and then solve it out directly, because I know some details already. I would not want to explicitly make it a step and then reason through it. So you have similar reasoning, just that you have compressed it into a shorter form. Now, this is what we call as chain of draft, and the earlier one was chain of thought, right? This is a very recent technique which has come up a few months back. So I would say if this spikes your interest, you should already be looking at this as well. And there would be newer models coming out which actually adopts these techniques as well. All right. So we looked at a lot of generative AI models, a lot of prompt engineering. How can you really use that to your advantage and get more detailed output, more personalized? But now look at the future of where generative AI models are headed. So that is a term that you would hear very commonly now going forward, which would be agentic AI or agents. So what really are agents? You already have that if you have used some of the subscription-based models. It could be ChatGPT or Gemini. You would have already seen something called GPTs by OpenAI, or you would have seen something called GEMs by Gemini. Again, these are actually agents. And again, the term is getting formalized now. You have a way to build your own agents as well, codify it, and make it more autonomous. So that is where the industry is headed. But in a way, you had these available already in your interfaces to interact. Now, I may give some spreadsheets and I want to get some data analysis done. That's where I would go with, let's say, a data analyst from ChatGPT, let's say. Or I may want to, let's say, write some codes. So I have a coding assistant available for me. I may want to play chess. So I have a chess champion available as a gem in Gemini. So you have different words. Somebody calls it GPT, somebody calls it gems, somebody might call it something else. But at the end, at the core, it's agents. Now, what really does agents help us achieve is, so we looked at, let's say, expert tuning in your prompt and similar techniques. So what you do here is you actually fine tune your model to work in a particular area. It could be maybe documentary writing, or helping you out with some analysis, writing codes. So that is where agent specializes in a particular domain. Once you have built that, you use that only for that particular use case, and then you have a different set of agents that you could really specialize them in some use cases and let them work that way autonomously. So autonomous is one important thing. You would want to automate a lot of things, and that's where agents are really helpful. You don't have to manually intervene every time, but let the agent do as much work as they can. And wherever really required, human inputs, maybe approvals would be taken. Uh, so what do you think really would be a best way you could use autonomous AI agent? Let's open up a poll for this, and you have some time to answer it. So would you use a chatbot to answer FAQs? Would you make a model that write essays from prompts? Or would you use a system that can plan trips and book a flight for you as from your inputs preferences that you give? Or would you use agents to build a text classifier? All right. So now we know that we have different use cases, and maybe from these options, I would say using agents to plan a trip for me and booking the flights would be the right way to use them autonomously. And how would that look like if we have a demo? That would be really great. So let's look at a demo of autonomous agent booking a flight for me. Now, what I'll do here is I'll say a starting location, which would, let's say, be Japan. And I would want to go to China, for example. And there are, let's say, 5 passengers. It's a budget trip. And I would have 10 days of trip for this. I would want to explore the culture. I would want to explore food and dining options. And maybe I am also an adventurous person. I want to see what are the different activities that I can also do, right? So these are some of the preferences that I've given. And before that, let me change the lightings here so that we are able to see the outputs better. Cool. So I want to create an itinerary for 5 people moving from Japan to China for a trip of 10 days, where I want to look at culture, food dining, and also experience some adventure trips if I could do that, right? So with that said, I would just click on this button, create my personal itinerary. And what would happen is, first I'll explain that we have different travel agents. One of them is specialist, which would identify the destinations basis my preferences which I've given. That is one. I would have an accommodation expert. Because I mentioned it's a budget travel, it would not give me very expensive deals, but it would rather find some good budget deals for me. Then I have a transportation planner who efficiently plans my routes and how I should manage them on these 10 days. Then I have activities curator because I mentioned maybe I'm looking at food, dining, adventure. So those are some of the activities it would also look at, dining preferences as well. And then finally, once all the agents have completed their work, I have a final itinerary creator who would go through all the details which it has received from different agents and compile finally everything together and give it to me, a day by day wise, itinerary creator. So let me generate this, and you would see the agents kicking out very soon. It's available right here. You would see the different agents are getting started. Let's look at the live activity. So starting destination research agent, for example, and other agents would also start. The agents have started and they have also started giving me the outputs. So for example, I was headed to China and you would see the top 5 or maybe the neighboring cities coming here, transportation options. So all of this is coming from destination research agent, right? If I go to accommodation, it would look at my details because it was a budget plan. It would keep that focus in mind and would look at deals accordingly, right? So different budget options, what are the challenges I could have. Seasonal wise, it is also looking at, because I'm traveling in May June period, which I mentioned, it would look at those details as well. And then you have transportation agent, for example, how would I transport within the city and all of that details. Once all of this is ready, let's look at, yeah, so once all of that is ready, you would have a full itinerary created by the final agent that we had, which was itinerary creator. So I'll give this some time, but imagine the details you would have to put in and also the amount of research you would have to do for this kind of a trip, a 10-day trip, number of YouTube videos you would see, number of Google Map reviews that you would go through to just kind of get a itinerary ready. Now, all of that in a few seconds, you have that available. Maybe you would want to customize this further, but this is a really good start that I would say agents are able to do. And all of this was autonomous. If you see, these agents were working autonomously, and finally the results were combined by the itinerary creator. This is what agents enable for you to do. You could automate a lot of things and then have your manual intervention as well. So going through the details, I may want to, let's say, have some modifications. So that is again possible. And these are some possibilities that agentic AI as a field would open up for us. All right. So individual agent outputs are available for us to review, and uh, that is something you can go through. Your final itinerary is ready. This was the last agent which was waiting for outputs from all the above one. And you would see this details are basically markdown, which is something generative AI models are really comfortable with. So you'd see markdown code, but basically if you render it properly, you would have a day-wise creation available, what you would do in the morning, what you would do in the afternoon, what to do in the evening, right? Basis all the preferences you have given, because I am, looking at a very personalized plan. And not just this, I am looking at a very detailed day-wise itinerary as well. If you just look at it below, right? So your individual agents have found out everything that they could, and finally, basis your preferences, whatever is more personalized or curated for you is combined, and a good enough itinerary is created and available. So your trip is in a way ready. This is a good example that we looked at from a agentic perspective. This is again a start of a new field, and you would see many developments happening on this over time. But with that said, what's next? So I would broadly classify this into a few categories. One of them is technical future, which is all about the current limitations. We looked at a few limitations already. Some of it was like the models do hallucinate even today. I was using the very latest models, but I was not getting the right images generated. The models are not good with, let's say, mathematics, and there are ways to overcome that with different prompting techniques. We looked at a few of them already, right? But that doesn't overcome all the limitations. There are still limitations with generative AI models, and we continue to evolve over it. There are advancements happening. That is one field. You have scaling limits in terms of compute, scaling limits in terms of data availability. How can the model really improve even further when they have already trained through all the public data available, right? So there are scaling challenges there as well. Then you have memory and reasoning difficulties. If you would have observed, when you are chatting with a generative AI model on some interface, if you have that chat open for a long time and you have a bigger conversation going on, the models would be responding slowly because you have a bigger context that the model has to process every time you work with it. So one way to avoid that is have newer conversations getting started and have maybe different conversations every time. But again, that's not very favorable. You would have some context in a different thread, and if you start a new conversation every time, how do you really bring that together? So these are some challenges that are getting addressed. You have bigger memory footprints that the model can work with. These are some actual advancements happening right now as we speak. Other is reasoning capabilities. They are not good with mathematics, and that is one of the founding principles of how you would reason, right? You need to be good with your logic building and use step-by-step approaches to work further. So again, an active stage of development right now. Some ways to use your personal data is RAG that we looked at, and you can use some tooling if you are going on the coding side of things. So again, how do you embed your personal data, make your models work with it? Active field of development which is there. And autonomous agents, of course, which we looked at, which is where the future is headed. Agentic AI is all about making it autonomous, and you do not have to just sit and prompt, but rather keep it autonomous and let the agents do most of the work for you. Next is social economical factors as well. Uh, how do we really have governance in place? Because left and right models are getting released. There is no central authority which is monitoring the development or keeping some governance in place. Companies are releasing their models. Some are open source, some are closed source. So how do we really have orchestration on top of it? And should all the models be open sourced? That could also make it a zoo, so to say. And if everything is closed, then how do you really rely on the outputs? That is another open question. Other is, let's say, would AI take my job, so to say, right? Is it job displacement or augmentation? If the existing jobs are getting away, so are you getting newer jobs in place there, right? So again, a factor where kind of something would be coming up soon. Next is alignment and safety. Now we looked at model outputs. We looked at a few limitations also where the outputs were not accurate as per what I would have expected. So in those cases, you would see a thumbs up, thumbs down kind of icon where you could give your feedback to the models, basically the companies training the models. Now that is where human feedback comes in. You as a human are giving feedback, and the company would use that data to train their newer models on top of it so that they have more accurate or more better results. And this technique which they use is called RLHF, which is reinforcement learning based human feedback. We looked at reinforcement learning right in the first slide, which was about you give positive rewards and the model learns on top of it. But there are some limitations with that as well. So there would be me as a user who is using a publicly available model, but how do you really rely on my feedback? Maybe I am wrong in the output that I'm expecting. I could have a different perception, right? So there could be those kind of limitations. Other is not everyone gives feedback. So I may just ignore giving feedback, maybe if it is right or wrong. So that is another challenge where you have sparsity in your feedbacks that you have, and the feedbacks you have, how do you really rely on it? So those are some of the real challenges here. But apart from it, is the model responsible? Responsible in the sense, would it stick to the output every time? If you just ask the same prompt again, or maybe you say, are you sure that this is the answer? You would see that is another limitation. You maybe ask a simple question, which is x plus 3 equal to 5, what is x? It would say some answer. But next time you ask, are you sure of the answer? It might change. Right? So is your model responsible? Can you really think that is it hallucinating, or is it very confident? And how do you make it interpretable from the prompts that you are using? So those are some alignment and safety questions that you would have. And next, I would leave you with a thought with this paradox of effort, as we call it, which is if you're giving full effort, that might be draining, but opposite is the case usually. If you're giving full effort, that is more energized is something you would feel, and more connected with the problem that you're working on. But with AI, if you are just giving a single prompt and you're able to get the output, are you really getting energized or not? That is something you should ask as well. So you could maybe think on these lines: is less more? Basically, using lesser models, doing more work yourself. Is that more, or doing less yourself is more? Other would be, if AI can do it, why should I even learn? Right? So, and other would be, am I automating expression? So I did a few prompts. We looked at many demos today. Was I really automating my expression? Because at the end, when you're using generative AI models, you are thinking, like you are having some expression in your mind and you are expressing that to the model, and model is giving you some output. But these prompts were kind of very generic. Everyone could do that, right? So is there some human touch that only I could do that output, right? So those are some of the things that I would leave you with a food of thought. Apart from it, I would also want you to do a simple exercise, which would be, we looked at different prompting techniques. One of them was, let's say, expert tuning. Maybe use that and fine tune your resume, or do some exercise where you are able to apply the techniques that you have learned and not just leave them on slides, right? So yeah, with that said, I would end it here. And you have a question form that you would want to fill post the session once it ends. Thank you, Ayushi and Karan, for having me here. If there are
Thank you
any
so much,
questions, I'll
Mayur.
open. Yeah.
Thank you so much, Mayur, for the insightful webinar. I think we all really enjoyed it, especially the travel agent part. It was great. Cool. So we have few questions with us. We haven't received questions on the Q&A tab. If you have any questions, please put it in the tab that you see, Q&A tab. And as of now, I can take up questions from the chat. So one of the question is, what are the advantages of compressing the model weights? How does the compression function?
So there are different ways you could do compression. We did not touch that in the slides because again, that was a more advanced topic. So there are some techniques as you do transfer learning. Similarly, you could do knowledge distillation and do your own model training by yourself. Those are some of the ways. Uh, Advantage of that is, let me quickly show you a demo that we went through, which was this coder demo, right? So giving the prompt with a 32 billion model maybe takes 5 seconds, but if I use a 0.5 billion model, you would see the difference. So let us quickly do that. All right, I'll just copy the same prompt, write a snake ladder game using Pygame. I'll copy this prompt and you would see the difference in the output. So when I do send, you would see the model would be very fast in answering. If it works now, all right, so you already have the answer, I believe, with zero point 0.5. And when I was doing the demo with 32 billion, you saw that it was actually typing it out, right? That is one difference you would see with compressing the models. And other would be, faster. If you are deploying your models on the client end, you would have faster download speeds and model is responding faster. So those are some of the advantages.
Amazing. Do we have any more questions? If you have, we still have few minutes. You can just put up your questions here. Okay. If you do not have questions, then please, if you come up with questions later on after the webinar, then use the link that Mayur just showed to you, the post session question form. You can fill that, and we'll try to answer them via email. So yeah, I think we're good to go. Thank you so much for joining. We Once you exit this webinar, you'll have a feedback form. Please feel free to give us the feedback, and we'll improve based on that. Thank you so much for joining. See you. Bye bye.